Emmanuel next. Okonlawo Emmanuel. All right, so Emmanuel will be telling us about debugging. Now, let me just tell you. Expect. Anyway, let me not brag too much, but forget. Emmanuel is a Thanos Wakanda kind of thing. So you're gonna really enjoy the talk. So Emmanuel Okonlawo will be talking to us about debugging Node.js applications. You can transfer the knowledge anywhere. So he'll be talking to us about the event loop, right? Understanding the event loop, sorry. That was a mix-up here. So he'll be talking to us about understanding the JavaScript event loop, right? So make sure you listen attentively, all right? Write down your questions. We'll have time for questions as well, so you give us your questions as you have them. Thank you very much.
Yeah. Hello, everyone. My name is Okonlawo Emmanuel. I'm talking about the event loop. So before I start, I would like to know my audience so I can know the perspective I'm talking from. You've heard about event loop before. Can you just wave? Event loop, you've heard about it. And you've heard about the face of event loop. Can you wave your hand? Yeah. Can you wave? Okay. The phase. I've heard about round robins and stuff like that. So, okay. You're a PHP developer. Can you wave? Okay. Thank you very much. So, yeah, my name is Okonlawo Emmanuel, full stack web developer. Currently leading an amazing team at Obic Tech. Actually, I forgot to add my Instagram, my social media handle. If you can observe, that is kind of new, so I added it now. So that's my handle. You can ask me questions, and I'll definitely reply. So people call me Solar. Yeah. So let's go to the main deal. Yeah. Event loop. We all know that Node.js is actually single-threaded, and it is asynchronous in nature. Yes or yes? Yeah. So, because definitely, we all know that. But the amazing thing, we know that the amazing thing about Node.js is that Node.js is fast, right? And it's good for writing real-time stuff. And Node.js enables us as a kind of a JavaScript lover to write JavaScript on the server side. And for that to be possible, we know that Node.js is built on the Chrome V8. Yes or yes? Yeah, so we know that Node.js is built on Chrome V8, which allows us to write JavaScript on the server side. That's not the main problem. That's not really why Node.js is existing. One of the most important reasons why Node.js is existing is because the fact that the way operations are being handled, there's a new there is a better solution to handle operations. Now, in Node.js, unlike other server environments, the way operations has been handled is actually different. When I mean operations, when I mean I/O operations, we all know I/O is input and output, right? So when I mean I/O operations, I'm talking about accessing disk or network resources. So Node.js actually have a great solution on handling what? Slow I/O operations. You understand? So I think I've talked about, yeah. So Node.js actually have a new perspective of handling slow I/O operations. So these slow I/O operations can be time consuming. For example, getting a request from an external server and stuff like that. These are operations that could take time based on the type of operation you're actually requesting for. So how does Node.js work? We said Node.js is based on an event model and it's organized by something we call event loop, which is something we're talking about today. And this same event loop brought about the non-blocking nature of Node.js. And when we're talking about the non-blocking nature, we're talking about what? We're talking about the asynchronous behavior of what? Event loop. And I said something about the asynchronous behavior of event loop. Node.js allow as a mechanism, which is what? Which is the event loop we're talking about. The event loop enables Node.js to perform these operations in a way that it won't affect the main execution thread. Now, we have to understand these two terms before I actually go deeper. Blocking codes and non-blocking codes. What are blocking codes? And I would like to actually show you guys so that we can get this right. Blocking codes are like like a normal sequence of instructions. Step 1, assign a variable. Step 2, increase the variable plus 1. Are we getting that? So these are examples of blocking codes. And also, there's this kind of misconception. People might think when you write some code and you maybe did a kind of a callback system like this, some code that we run after some execution of codes. Some people think that is non-blocking code or asynchronous code. No, it's still the same thing. You are still writing blocking codes. I think I would like to show it so that we can actually get what I'm saying, because it's very, very important we understand this part before I go into the complex part. Actually, understanding this will enable us to build more interesting softwares and performance friendly software. Please, you can join the session live here. Please, you can join this session live. Can you see this link? This is bit.ly 2NA8PEB. Yeah, capital letter N, small letter A, 8PEB. So, because it's very, very important we pass through this stage, because by the time I start to explain the face of the event loop, it might kind of look funny. Yes, why is this talk existing? This talk is existing because when you're writing Node.js, it does not tell you that because Node.js is asynchronous in nature, that does not mean that you can write codes that are synchronous. Are we getting that? That does not mean that we cannot write code that are synchronous. That does not mean that we cannot write codes that are blocking, and which is very, very bad. It came to solve a problem, which is what? The way asynchronous request is being handled and stuff like that. And we should not be going otherwise. We have to follow the same direction. Are we online? If you're here, can you just wave? Okay, so let me just proceed. I have this short snippet here. Looking at this snippet, we have a function that do what? That accepts two parameters, which is A and B. That is, it computes these two parameters. And we have a for statement. This for statement is just kind of a delay. This for statement runs nothing. There's nothing inside this place. It's a kind of a delay to just show how these blocking codes. So now, if I should run this on the terminal, please don't edit the code, though. Let me disable it. Actually, this platform is very, very nice. I really like it. So I'm pasting this in the terminal. I want us to observe the behavior. So we have a functions that do what? They add two numbers, and we assign these values to a particular variable, and we console.log it. Let's look at this behavior. Do you see what is happening here? The functions have to stop to go back to the what? To the function itself and run the code. Go to the next line, go back to the function, run the code, go back to the function, run the code. Do you see what happened? Is that the same thing? Are we getting this? Actually, everybody can get it today. You understand? So let's just pretend. If you're not getting it, just pretend you are getting it. So let's continue. Basically, what is happening is that we have a function here. Yes, we have a function here. This function add two numbers, but before it add these two numbers, there's a delay, and the delay is what? We have a for statement that keeps running until this condition is what? Is false. You understand what I'm trying to say? We all know for loop now. If you don't know for loop, you know for loop Twitter handle. So that's it. So that's basically what's happening. And we all know how functions works. When you assign a function, when you assign a function to a variable, what happened? It's a reference. Are you getting it? It go back to the function, run what's inside, and pass the value and stuff like that. So these kind of codes are blocking codes. There is nothing asynchronous inside. It's still blocking code. Even when you do something like this. This thing is just too big here. You guys are enjoying it here, but I'm not. So even when you have a callback, attached to that kind of function, and we all know what a callback do now. A callback, we use callback when we want to do something after some process has been accomplished. Even when you have a callback into something like this, it's still not a asynchronous code. It's still blocking. It's just that you are kind of putting a logic that before this code run, do all these things first before this code run. And sometimes those code might be dependency. Maybe you need some data from those code before you can actually do before the callback can actually make sense. And maybe, for example, the code, there is an error and stuff like that. You could actually do some reject and stuff like that. That's what blocking code is. Let me show you what a non-blocking code look like. On your system, I think you'll have seen a section I comment. I did something like non-blocking. So we have this non-blocking code here. What happened is that what we're actually doing is that we have the same function that add two numbers, but this time around, we are not performing the delay inside that same block. Instead, we perform the delay inside a set timeout, and continue with the process. Now, this is where we start to think about this set timeout safe. I know that whenever I set timeout, it won't happen immediately. Maybe after some time, it will happen. So to understand the logic behind how these things work, we only have to understand how event loop works. And by the time we understand stuff like this, we can now, for example, now this platform we are using, this sandbox editor and stuff like that, they work. Wow, I'm seeing someone here. They work on serious IOs, and the real time is not something they joke with. You understand? And when we want to start writing apps that deals with real time and stuff like that, we need to really understand how these things work, because we can actually knock Node out itself if we're writing bad code. We can actually make what we are preventing happen. That is slow IO operations. We are preventing slow IO operations. That's why we're having event loop. event loop. That's what we are preventing. You understand? We don't want slow I/O operations to delay other logic in the application. So now this code is the same thing, but the difference is just that the delay is not inside the same level. We have the delay is inside what? A set time out. Now, if I should run this code, who can tell me what will happen? Oh, that's too much. Now, do you see what happened here? After running that code, there's no delay. Everything ran very fast. We don't have any delay. If you this kind of person that watch science fiction film, we know we have timelines now, right? Like I say, somebody's in this popular movie now. What's this guy? Flash. At 1, at 2, at 3. I think they have at 10 now. So when they are maybe they are showing a particular scene in at 1, you'll find out that something is happening at 2. This is different timeline. You understand? So something like that is actually happening here. So the set timeout enable you to run some code in a particular phase in the event loop. We'll get there. So this set timeout enable us to run some code in a particular phase. Now the question is, when do I run this code in this phase? When do I do this? When do I do that? But you can't know until you actually understand what this event loop, what all these phases do, and why are they existing. So basically, I think I've successfully differentiate this blocking and non-blocking code so that I can move on to what I'm talking about. So I think I've talked about this. I said I/O is used to communicate the process of a computer CPU and anything external to that process. That's what we know I/O as. But when we're talking about Node.js, we're talking about disk accessing or network resources. So now, I said something about handling slow I/O operation. We have this method we have this various method in handling slow I/O operations. First of all, synchronously. That is holding up other requests. For example, the first code I show you guys, which is what? Blocking codes. It's similar to, that's a synchronous request. That is, one has to run before the next one, and after that one, it has to. So the disadvantage is that it holds up other requests. For example, maybe you even you want to do something that is not even related to other things. It's going to delay them until those requests are being given response before it goes to the next one. Also, we have fork. So for fork, what happens is that for every new I/O request, it creates a new what? It creates a new process. So a process is something in execution. So it creates a new process. For thread, every new request has a new thread. For example, Apache web server, PHP guys. The PHP creates, I'm a PHP developer. In fact, I eat PHP, I sleep. So for the thread, for every new request, a new thread is being created. But NGX created a solution for that. They also use something like event loop to handle requests. That's why you see that NGX is faster than Apache. So, and in this case, we're talking about what? Event loop, which is what Node.js use. So Node.js use event loop to handle requests for slow I/O operations without blocking the main single thread execution. like I already said, this is the most important aspect of what? Node.js itself. We can do a lot of things with Node.js, but for it to be a very kind of a badass Node.js developer, understanding this is very, very important. Yeah, we have different definition of Node.js. We said Node.js is the entity that undo external events and convert them into callback invocations. I have a diagram that will explain this better. Also, a kind of more technical definition. Node.js event loop is the guy that summon event from event queue and pushes their callback into call stack with order of operation, which is referred to as what? Face of what? Event loop. That is, when it is pushing their when it is pushing the callback to the call stack, there are some let me just say there are some process it has to go through. So it has to go through a process. That process is called the face of event loop. So the misconception of Node.js, they said event loop runs in separate thread than the main execution thread. For example, when you like what we ran the other time, the non-blocking code, we get to see that the code ran so fast that you'll be wondering, what about the delay? Where is the delay running? So people think it's a separate thread. No, it's not a separate thread. And also, we have event loop in the browser. Do you know that we have event loop in the browser? Can you wave? Can you wave if you know we have event loop in the browser? Okay. So we have event loop in the browser, which also manage how requests are being handled. For example, your XML HTTP request. It's actually a browser API. It's not JavaScript stuff. So these things have similarities. We'll talk about that too. Now, things to know about this event loop. Event loop is what talk about that. And also this one. I don't know. Have any of us used this std in resume? Standard input resume. It actually makes up. It enables us to get the event loop very, very busy. Like it's just going to get busy. It's not doing anything. If you observe when you run a script in Node, for example, maybe you have something that adds two numbers together. Immediately you run it. Immediately the execution finish is going to tap out. Do you get that? Like it's going to tap out from the execution. That is, it will end the execution. So what basically happens is that immediately you start the script, event loop starts. Immediately the script is invoked, event loop starts, and immediately the execution stop, event loop stop. So to get the event loop busy, you can actually use something like this to get the event loop busy. For example, I know a lot of people will have run into this mistake. Maybe when you are creating a server and you didn't use something like rest send. What will happen? The browser keep rolling. Do you get that? The browser keep rolling. What's happening? You are not doing anything. You are not responding to requests. You are not doing anything, but it's still on the same function. It's expecting something to happen. So the browser just keep running. The event loop is busy. Now, this is basically Node. So everything that happens in Node revolves around this guy. Now we said Node.js is built on what? V8 engine, right? So this is the V8 engine here. So the V8 engine has the heap and stack. And we also have Node APIs, and we also have the event queue. Now, this heap handles everything, talking about memory allocation or stuff, anything about memory allocation. This memory and stuff like that. This stack, which is also known as the core stack, this is where the executions. This is where the execution happen. This is where the execution happen. And these Node APIs, we said something about Node. We said Node.js is actually a kind of a wrapper that enables us to do what? To perform to do great things with JavaScript. Am I right? So, in this Node API, we have a lot of APIs. Example of APIs we have set timeout, we have fs read file, we have emitter .on. And if you observe, I don't know if you know, if you observe, all these APIs are what? Asynchronous in nature. Yes or no? Yes or no? All these APIs are actually asynchronous in nature. And they also have a what? They have the other part. They have the synchronous version too. Am I right? So, these APIs enable us to do what? To interact with what? With the operating system. These APIs enable us to interact with the operating system. JavaScript is not reading files. Are we getting it? JavaScript is just JavaScript. JavaScript, like, just enable us to do some JavaScript stuff. So these APIs are a kind of a JavaScript, they are APIs that we can use in JavaScript to do what? To interact with the what? With the operating system. And we have this guy here, event loop. The job of this guy is to do what? Okay, before I go there, let's take it. Let me. Okay, I've explained this. Before I go there, let me just take this thing step by step so that we can all be in the same page. So now, I said something about the core stack. The core stack is where the execution happens. We all know this guy now. Am I right? So, this is Pringles. If you don't know, this is Pringles. And it is potato something, you understand? We eat it when coding. What do we do to it? Okay, so this guy is very unique in his own sense, because I want to use it to explain some data structure, a particular data structure, not just many, just one. And the data structure I want to explain is stack. We have core stack. What is stack? Stack follows a kind of first in, a last in, last out, a last in, first out, a last in, first out flow. That is, we have a lot of, what do you call one this thing? What do you call it? Eh? What do you call it now? Pringlet. So, okay. Let's do it this way. Let's assume all these things are what? All those things are functions. Are we getting it? Let's assume all those slides are what? Are functions. So, Pringles will tell you that when you insert the first function, you will take it to until for example, we have the first function, the first function enter, the second function enter, the third one, fourth one, fifth one, sixth to infinity. But when you want to take the first function, what is going to happen? You have to take out all those functions before you take the first function. That's what a stack is. And that's what stack data structure is. So basically, we already understand what core stack is. Core stack will execute every function that enter it the way they actually get in. Before I execute you, I will execute the person that gets in before you. Though it's bias, oh, you know it's bias. Like imagine they start sharing stuff, and I said because they start sharing stickers now, and I said it's the last person that come that will first. Does it make sense? You are the last person. Wait, how does it? Yeah, the last person that come is the first person that will first take the sticker. That's very bad. So that's what core stack is telling you. So we also have the event queue. Like we all know, I think this is explanatory enough. Event queue follow a kind of a first in, first out. A first in, first out, that is the first person to come is the first person to go out. So we have to understand this data structure to get running with. Now, we said something about event loop. We said event loop is the guy that someone event. Please, let's take it in. Are you getting it? So we said event loop is the guy that someone event from the what? Event queue and pushes their call back to the call stack with an order of operation which is referred to as the face of event loop. Now I'm going back to the diagram. Now we said what does event loop do? Event loop summon what? Event loop summon what? Summon, huh? You said? Someone event from the what? Event queue and pushes their what? Their callback to the what? To the call stack. Event loop someone event from the event queue and pushes their callback to the what? To the call stack. That's the job of event loop. So the problem now comes when we are not trying to know the face of event loop. That is, how does it really do it? We know this is what you do. So how do you do it? And what determines my function is going to this place, to this particular face, and to this particular face. So this is where this guy comes in. To get more explanatory details about this guy, you can actually go to the Node.js website, even though you have to read like 5 times before you have to digest it. I don't know if you have tried reading that document. Something event loop, nestic, something. Who have seen that document before? The thing is just so, you read it like 5 times. More than 5, self, before you actually digest it. And I don't know why the fuse is there, because basically I get to understand that it's normal to humans. Now we have the timers. So the example of timers we have the set timeout, right? And we have set intervals, and we have what? We have set timeout, we have set intervals. Now, when you run a code with set timeout or set intervals, it goes into this phase. It is executed during this phase. Are you getting it? This timer phase. Anything that runs inside this phase, it means that particular code is being triggered by what? Set timer or what? Set interval. This guy. Now, pending callbacks. Pending callbacks, don't worry too much about it, because mostly it's made, for example, maybe there's a TCP request and you want to, and there's an error. So they can just pend the error to the next distance. So those kind of stuff goes here. This idle and prepare is for internal use. Node itself is for internal use. Now this guy, this poll actually controls how this guy work, or when this guy work. The poll control when this guy work. Meaning, I look at this poll as the kind of the most visited phase. Are you getting it? The kind of the most visited phase. That is, when you are in this poll and you run, when you are in this poll, it means you are actually in an I/O cycle. Are you getting it? That you are actually in a kind of an I/O. When I say I/O, I mean accessing disk or network resources. You're already in an I/O cycle. So when you are in this pool, and inside that I/O cycle, you can actually do what? Maybe do a kind of a set timeout or whatever. So when you do that kind of thing, what will happen is that because you did that, you've made something available for this guy. So at that moment, Node.js will do what? We block this guy and go attend to this guy. Are we getting it? Hello? Are we getting it? So at that moment, Node.js will do what? We block this guy and go attend to this guy. Immediately there's nothing here to come back and continue the process. Now, when it's actually continuing the process, and also when there's nothing to do, what this guy will be doing is that this guy will be listening for what? Incoming connections and stuff like that. Listening for data and events or stuff like that. Anything that's likely to happen, you understand? That's what that guy do. But if there is job here, which is what? This check phase. If there is something to do in this phase, it will do what? It will go to the check phase and perform all these operations. Now, the question is, how can I get my code inside this check phase? When you use set immediate, have you used set immediate before? You've used set immediate, please wave. Wow. You have used next, why am I, next set, sorry. Let me just get away from that. So when you use that, it's not with the face. But have you used that before? You don't even know what I'm talking about, so I didn't even mention. Net set tick. Have you used that before? Have anybody used that before? Yeah. So when you use net set tick, what it does is kind of funny. It's not. You can see that there's nothing talking about net set tick here, because this check only does what set immediate invoke. When you do something with set immediate, all these are functions. In case you don't know what I'm talking about, these are functions. They are Node.js APIs that enable us to do some things with the operating system that make us take advantage of the operating system itself. You understand? So this set immediate, set next tick and stuff like that. So this set immediate push your code to this what? To this guy here, this check. So when there's something available here, this guy won't be waiting for incoming connections. This guy will go to this guy and execute everything that is inside his face. So when this is done, you can go back and be listening for incoming connections and stuff like that. Also, we also have this close callback. This close callback undo event that deals with close of some connections. For example, close on socket and stuff like that. So this is what close callback deals with. You know, you're actually ending something. I think that's why they put more stuff on that. So now, set immediate enable us to, we push codes to set immediate. That is the reason why we are pushing code to set immediate. It might look funny. It's not because we want, don't think it's because you want the code to run immediately. That's why we are pushing code to set immediate. There is a kind of confusion, and that confusion was actually born to confuse everybody here. That's just the basic truth. Because we have set immediate and we have set next tick. Wow, why am I having difficulty pronouncing that stuff before? So we have these two, and these two is a kind of, what they do is kind of funny to their names. Because set immediate will tell you that I will execute this code when in the next iteration. Are you getting it? That's set immediate. Next iteration. But set next tick will tell you I will execute this code immediately I'm done with what I'm doing. Are you getting it? Immediately I'm done with what I'm doing, like what I'm currently doing, I will execute this code. Now looking at the names, what do you think I should name set next tick? I will name it set immediate. But I don't know why these guys are just like that. They just want to confuse everybody. And that's it. Even their documentation is telling you that the names are funny. Node.js documentation itself. They are telling you the names are funny that you don't. So basically, this is what these guys do. Now, what's the essence of all this explanation? You are performing a kind of a IO request, and you kind of check for some parameters or stuff like that, and it's not available. So basically, without knowing all these things, you just want to end it and continue. But if you don't end it the right way, you might actually be jeopardizing with the reason why Node.js is existing, which is handling slow I/O operations with what? With care. You understand? So the fact that we have these Node APIs, set immediate, set next tick, set timeout, set interval. If we know how these things works, we can actually build better apps by utilizing all the time we have. We don't have to waste any time. So by utilizing all the time we have. So now let me visualize all these things we talk about with a tool like that. It's one guy that did it. So they call this stuff Lupe. Is Lupe? Yeah. So this code is actually this stuff is actually built to illustrate the browser event loop. Are you getting it? So it's actually built to illustrate the browser event loop. You know, I told you there's an event loop on the browser side. It's actually built to illustrate the browser event loop. But we can also use it to illustrate Node.js event loop. But the part we can't really illustrate is the event, the face of the event loop. We can't see that face. But you can actually see how the event loop take stuff from the callback queue and push it to the call stack. So I have a code here. This code has two numbers, and it is not asynchronous. It is blocking. I want to see how that reacts. I want to see event loop in action right now. So I'm running this guy. So save and run. Do you see what's happening? So let me reduce the timer so that we can go about this faster. Please look at the code now. We have this function. We've run this before. So we have this function, add numbers. So this function assign this function to this particular value, and we console log the output. Now we want to visualize what's happening behind the scene. That's just what we want to do now. So I'm running this. So now the first thing is to what? Add 10 and 10 to what? To value 1, right? So we are executing this first function. So inside this function, we have what? We have a for loop inside, right? So it's still running. It's a delay. So it's a kind of a delay we did. It's a kind of something we fabricated. So this delay keep running. When this delay is done, it goes to the next thing, which is what? And this delay is too much. So let me reduce it more. I think it's taking it one by one. So let me just reduce it. So we're counting 9, right? This is the first iteration. I think this is the 5th iteration right now. So do you see what happened? After the delay, it goes to the next line and executes that code. It goes to the next. The next step is to do what? Perform the same function, assign it to value 2, right? So it's doing that. If you notice, the event loop is not in action. Am I right? The event loop is not in action because what we have been doing is just a normal blocking code. We're not doing any asynchronous job here. So the event loop is not in action. So it's just the call stack in action. And I said something about the call stack. I said the call stack takes the last what? The last thing first out. So what was the last thing? The last thing is what? The last thing is what? The function executes. Am I right? Which is the first thing? One. The function executes. The next thing is what? The for statement. After the first statement is what? The return. Don't forget, this is a first statement. On a norm, this first statement should have a body, right? So after the first statement, it returns a value, and immediately it returns a value. Definitely, it means you are existing this function and pass whatever you return to the variable. So that's basically how it works. It works in a stack direction. So now let's just go to the non-blocking part. I'm commenting this out. And now let's run this. Now, in this case, the first statement is inside what? A set timeout. Right? So let's run this. Okay, we can still use this to just illustrate it here. So it's running another code entirely. So it's running another code entirely, but it shouldn't be doing that. So what this code is doing is that this code listening to an action that triggers this function. So just assume this is a function. Are you getting it? This is a function, and this function has a set timeout, and the set timeout is to do what? To console.log something. So now, we said something about set timeout. We said whenever we invoke set timeout, what will happen? It goes to the timeout phase, right? That is definitely the event loop is in action, right? So immediately, this particular code run. No, in Node.js we said there is similarity between this event, the way event loop work and how the runtime actually works. So in Node.js we have call stack and we have what? The heap. And we also have Node APIs. But in this case, because I'm just using the browser visualization as an example. So in Node.js, this is what? The Node API. Are you getting it? So we have similar names, so which is still fine. So now we have the timeout. So the timeout is an API, is a Node API. So that's why we have it here. So this timeout, what does this timeout do? This timeout pushes whatever is inside the check phase, right? Inside the timer phase. And whenever that kind of thing happens, it means the node, the event loop is in action, right? So now, check this. I'm resuming. Immediately, the set timeout run. Immediately, the set timeout run. We observe that every other thing in the main module continue running. Am I right? Am I right? Every other thing in the main module continue running. Don't forget, this set timer has a what? Has a time constraint. That is, before you run this code, wait for a particular milliseconds. Am I right? And don't take this as the exact time it's going to run, because the thing is that set timeout, when you specify these milliseconds, what we are just saying is that by the time this millisecond is elapsed, please run whatever is inside if this process is done. You're not saying that immediately run it. It can't. Until whatever is inside is actually done. That's when it's going to run it. So run whatever is inside. When this time elapses. But it's a condition. Make sure this time elapses first before you actually run this stuff. So let's just. I think this is just the class is ending here. So the timeout is what? The time is counting. See, immediately the time exhausts, it pushes to the what? To the event queue. Immediately this is done, it pushes to the what? To the event queue. And when it pushes to the event queue comes with the what? With the callback itself. That is whatever you ran, whatever you inserted in the brace. So it pushes to the event queue, and the event loop job is that whenever there is something here, do whatever is required of you and push it to the call stack. And the rule is that this guy must be empty. The call stack has to be empty before you push something there. So immediately the call stack is empty, you see that it pushes it. So again, we have set timeout. It continues to the process. Immediately we have something empty. Immediately this is empty, it pushes to the call stack. So that's how the event loop works. Thank you very much.
Woo. Thank you very much, Emmanuel. Thank you so much. So, because of time, we won't be able to take questions, all right? But I'm sure you heard set immediate, set timeout, set interval, set next tick, set next node. What else did you hear? So you heard all the sets, Abby, and the next. Okay, so or maybe should I take one question? Is there a question? Let me. Is there a
Is there
question?
any question?
One person, please, just one person. I think so.
Good day. Please, can you kindly go back to the slide whereby you are showing the timer? Please.
This guy, right? This is actually event queue. I don't know. Something is just it's event queue.
No, the other one that you are trying to explain.
Okay, the face.
Yes, the face. Yep.
Yeah, this guy.
Uh-huh. The last example that you gave,
Yep.
can you use this to explain it?
Okay, the last example.
Yes, the last example that it's about timer too.
Yeah. Okay.
Thank you.
Very fast. The code, what we did in the code is that we did set timeout, right?
Yes.
We did set timeout and what? And that's all. That's all we did in the code. So immediately we ran that code. The first, the main module is not yet in the event in the IO cycle. It's not yet there. But immediately we invoke what? The set timeout. Event loop will wake up. Event loop's already up already. But this guy listening to it, this guy listening to something has been, something has come in. And what this guy do is that it controls, we said this guy controls whenever this guy is doing something. So immediately this guy pass that job to this guy, the timer. So the set timeout is running inside his face. Are you getting it? And the rule is that before it runs, it has to elapse that time and stuff like that. So basically, that's just it. So after that, it will leave the IO cycle and continue whatever you're running.
Thank you.
Yeah, thank you very much.
All right, thank you very much.
Yeah, I hope we, if not completely, we a little bit understand what event loop is. Yes or no? Yeah, thank you very much.
All right, thank you. Thank you so much. You understand, eh? I know you are genius. I told you it's Wakanda level. You thought I was playing.
You